Hello, Ms. Buchanan's Algebra 1A students. We're looking at the real world graphs activity. And I don't know if you missed this in class, it's probably a lot better from in class, like especially number 1. But let me just go through this in case you missed it. The graph shows the height of a roller coaster during a single ride. Describe the roller coaster ride. So, I mean, you could get as descriptive. I got a little bit too descriptive, but you could pause that and take a look at what I wrote. But basically, what I'm writing is, and you could maybe shorten it and say, well, it starts off not any height, and then it hits its highest peak, and then it goes down to its original height, and then it hits another peak, and then comes down, and it's about halfway up, and then it hits its last peak, and then it comes down back to its original at the end, original height at the end of the ride. So anything like that would work. For number 2, your graph should look a little bit something like this. It could look better than mine, probably. So in a single day, it snowed lightly during the morning and then heavy for the rest of the day. Graph time on the x-axis and amount of snowfall. So starts off low, and then it gradually goes, and then it stays heavy. Number 3, Mia bought a painting. The value of the painting dropped by 25% after 1 year, then increased in value over the next 5 years, reaching a value that was twice what she had paid for it. Graph time on the x-axis and the value of the painting on the y-axis. So it decreased in value, stayed low for a little bit, and then shot up. That was twice as high, so I tried to go up twice as high on that one. I could have gone a little bit higher maybe. This one, the basketball's dropped, and every time that it bounces up half as high, half as high, half as high, half as high. So this is the distance from the ground, or height, and this is the time. Number 6, Jace is speeding on the highway, gets stopped by an officer, is down there for a little bit, talking to the officer, getting the ticket, and then goes, and this probably isn't like straight up, it could be more like a curve, slowly gets up to speed and is going at the right speed now. So probably look a little bit better like that. And I started this not down here because it just starts off that it's Jace is speeding. So Jace is just right off the bat speeding. That's when this graph starts. Carlos is a running back. He ran the same number of yards each first 6 games. So, this might be game 1, 2, 3, 4, 5, 6. And then he's injured and doesn't play for the rest of the season. So the amount of yards stayed the same, then nothing. Alice drives a school bus. Graph the time that the total distance the bus travels. So total distance the bus travels just keeps getting further and further and further and further. So that's just a general one. They're trying to trick you up with some of the other stuff, stopping and going. This is just distance. It's not speed. Okay, this one, running on a treadmill, heart rate goes up, stops to lift weights, and it goes up and down, up and down, up and down for the rest of the time. And as you read this one about spending money, Carrie spent a small amount of her money the first half of the month and spent the rest in the second half of the month. So a little bit and then the rest. Luke steadily spent his money throughout the entire month, so that's nice and steady going up. That's Luke. And then Mason spent all of his right at the beginning in the first half of the month. And then that was it. So when you're getting to this, I'm going to do every other one. What do the flat parts of the graph represent? The same speed. This is your speed isn't changing. You're not accelerating or decelerating. Okay. And then I did number 2 too. Circle the sections of the graph that show speed decreasing. That's going to be these 2. For number 3, what do the flat parts of the graph represent? So the distance, you're not moving distance-wise. So you're not coming back or you're not going further away. You're staying the same distance. So you're probably stopped. So that's why I have one stopped. So that's what stopped. Time still goes by, but you're not moving further away. Try 4 on your own. Number 5, what does section 12 to 1 p.m. represent? Going away from home. 12 to 1, you're going away. That's distance. Try number 6 on your own. Number 7, graph your speed as you travel from home to school. So speed up. I'm driving down Austin Road, and then I get here and I slow down. Okay. It could be a little bit more complicated because I do sometimes stop or I have to turn or something like that. So this would be just very general for yours. If you're just getting to a constant speed, then you pull in and you slow down and you get here and you stop. The speed of a person driving to the store for number 9, to stop at 2 stoplights. So they gain speed, they're going at speed, then they have to slow down and stop. Then they gain speed and then they slow down and stop. Gain speed, slow down, stop, then they get to the store. Try the evens on your own. Number 11, circle the section of the graph that shows the plane not moving. That's this section down here. All right, hopefully this helps, and good luck with your real world graphs.